Hi guys, it's Terry here. In this video I'm going to be looking at the solutions to the January 2022 physics paper, right? So figure 1 shows the arrangement of the apparatus used to investigate how the pressure of a fixed mass of gas varies with temperature, right? The cylinder is made of a very strong material which allows it to withstand high pressures, and it is sealed so that there are no leaks. Temperature sensor is placed inside the cylinder to give an accurate record of the temperature of the gas over a wide range of temperatures. A pressure gauge is also placed in the cylinder to record the pressure readings, right? So we have something to measure temperature and something to measure pressure. Now the first part of this question says, use the kinetic theory of gases to explain why the pressure of the gas increases as temperature increases. So this is a typical examination question, right? So the key thing that we need to answer here is that the pressure increases with temperature. So what we need to say, as temperature increases, right, the kinetic energy, because we're using the kinetic theory here, so as the temperature increases, the kinetic energy of the gas particles increases, right? So that's a key point here, right? So the kinetic energy of the gas particles increases, right? And what they do, they collide with the walls of the container, more frequently and with a larger velocity, right? Now what we need to say here is that is frequently, right? Right, so they collide with the walls of the container more frequently and with a larger velocity, right? This exerts a larger force on the walls, right? This force is exerted over the same area and pressure increases. Right? Because remember, pressure is given by force divided by area, right? So these are the key elements that you require here in order to get our 3 marks. Now, in the second part here now, so table 1 shows the results obtained when the experiment is carried out to investigate the pressure P in pascals with temperature theta in degrees Celsius when the gas is heated. So we have pressure and we have temperature, right? Just give me 1 sec here. Okay. Right, so what we expected to do, we expected to plot a graph, right, to represent we expected to plot a graph to represent this information, right? So there are several things that we are required to put on this diagram. The first one, we must label our axes. So we have pressure, and the pressure is given by 10 by 10 to the power 5 pascals, right? And what we are doing, we're getting that information straight from here. That's straight from the table. The next thing, we're going to plot temperature on this axis here, right? And that there is being measured in degrees Celsius. Again, that information is coming directly from here, right? So what I've done here, on the horizontal axis, every 1 cm represents 25 degrees Celsius, right? And on the y-axis, every cm represents 0.2 by 10 to the power 5, right? Now, what I'm going to do, I'm going to plot the temperature here, right? The first value is a temperature of 25 degrees and 1.2. So 25 degrees and 1.2 is up here. That's the first point. The second point is 50 against 1.3. So 1.3 is somewhere here. The next point is 75 against 1.4. That's here, right? The next point is 100 against 1.5. That's around here. And the next point is 125 against 1.6. That's here. And the last point is 150 against 1.7. So 150 against 1.7 is across here, right? So as we can see, that looks like that's going to give me a straight line, right? So you're going to take your ruler, right? And then you're going to draw a straight line, right? So that's your line here of best fit that I've drawn, right? So this is what your graph should look like. The next part now, so that was this part here. Use the results to plot the graph, and you're getting 6 marks to do this, right? The next part, part 2, extrapolate the line to meet the temperature axis and mark this point X on your graph. So what I've done, I've actually gone back here, and that's my point X here on my graph, right? So I've extrapolated it until it reached my temperature axis. Now, they said state the temperature value at this point and the name given to this temperature value. So, this particular experiment here, right, has to do with my pressure law, right? And when you extrapolate your graph, what is supposed to happen is that that graph, when extrapolated, it goes to a temperature of minus 273 degrees Celsius. That is what we should get when we extrapolate the graph. And the next thing, they want to know the name of this temperature value. Well, the name of that is what we call absolute zero. Right? So that's what this is. This is absolute zero. The next part now, they want us to work out the gradient of the line. Now, if you want to get the gradient of the straight line here, all we need to do is to select any 2 points, right? Any 2 points that we want. So I'm going to choose, so let's say I'm going to choose this point here, right? That point there is 0 against 1.1, right? That's 1 point I've chosen. And I can choose, now the thing is, all the points actually lie on the same straight line. So in this particular instance, I can use a point that is actually on the line, right? So in this case here, it'll be 125, right, against 1.6, right? So those are the points that I'm going to choose. 0 against 1.1. So let's see that. So the first point is 0 against 1.1. The second point is 125 against 1.6. Right? So those are my values there. So the next thing, what I normally tell my students, right, to do is to label these points. So we're going to call this x1, call this y1, we're going to call this x2, and we're going to call this y2. Now, to find gradient, right, because that's what I want, gradient, right, is equal to, and there's a formula, it's y2 minus y1 over x2 minus x1. So in this case here, my y2 is 1.6, right? Minus 1.1, right? All over 125 minus 0. But here's the thing. If you remember from the graph, this is what your pressure is actually here. It's by 10 to the 5, right? So therefore, this piece on top here is actually by 10 to the 5, right, Pascal. So what I'm going to get here is 1.6 minus 1.1, right? That's going to give me 0.5. So this is really 0.5 by 10 to the 5 all over 125. So therefore my gradient is going to be 0.5 by 10 to the 5 divided by 125, and I'm going to get approximately 400 as my answer, right? I'm getting approximately 400, right? So it's going to depend on how you draw the graph. It's really going to depend on how you draw the graph. Right? So in my case here, I'm getting 400 as my answer, right? Let's double check and make sure that's 0 against 1.1, and that's 125 against 1.6. Yeah, that seems okay, right? So that's my answer there, all right? Now they didn't ask us for any unit, so I'm not going to put any unit. The next part, part D, they said the sentence below is an incomplete statement of the pressure law. Complete the statement by filling in the blanks, right? So for A, fixed mass of gas, right, at constant. Now this here is the pressure law, right? So remember, the pressure law looks like this. P1 over T1 is equal to P2 over T2. So in this case here, your volume is being kept constant. So for a fixed mass of gas at constant volume, right, the pressure is directly proportional to the absolute temperature, right? When we use the word absolute, that tells me that we are using my Kelvin scale, right? And that's it. And the last part, in the experiment on page 6, right, the pressure, so the initial pressure, P1, is equal to 1.2 by 10 to the 5 Pascal. Right, your initial temperature T1 is equal to 25.0 degrees Celsius. However, once we are using the gas laws, we need to remember that we must convert to Kelvin. So this is 25.0 plus 273, right? And that's going to give me what, 298 Kelvin, right? So that's my initial temperature. What else did it tell us here? When the cylinder is heated, the pressure, so your P2, right, is 2.1 by 10 to the 5 Pascal. And your T2, we don't know what that is, right? We don't know what T2 is. They want us to calculate what is T2, right? And they said they want to answer in degrees Celsius. So all we're going to do, we're going to apply the pressure law, which is P1 over T1 is equal to P2 over T2. So your P1, your initial pressure, is 1.2 by 10 to the 5 all over your initial temperature of 298 Kelvin, which is equal to P2, which is 2.1 by 10 to the 5, all over T2, which we don't know. So to solve this, all we need to do is to cross multiply. So 1.2 by 10 to the 5 multiplied by T2 is equal to 298 multiplied by 2.1 by 10 to the 5. So therefore, T2 is equal to 298 by 2.1 by 10 to the 5 all over 1.2 by 10 to the 5. So therefore, T2 is equal to, so that's 298 multiplied by 2.1 by 10 to the 5 divided by 1.2 by 10 to the 5. And I am getting 521.5. Yeah, I'm getting 521.5, right? So this here is 521.5 but that answer is in Kelvin. In the question, they said they want the answer in degrees Celsius. So therefore, your T2 in degrees Celsius, all we need to do is to subtract 273 from this. So 521.5 minus 273 Kelvin, and I'm going to get 248.5. So this is my answer, 248.5 in degrees Celsius, right? So that's the end of question 1 in the January 2022 paper, right? For those of you who were asking online, yes, I do give online CSEC physics classes, and that is maths, admaths, physics, and chemistry, right? You can always send me a WhatsApp on this number here if you all are interested, okay?